Hey, pre-calculus. This is the second part to section 4.7, which is all about the inverse trig functions. All right. The first part asked you to look at the graphs and try to figure out what they were, and really kind of talked about those restricted domains. This part is actually more about evaluating. So actually trying to come up with an answer, a specific problem. What might help you today is to kind of go back to the hand method to help you out, or to review maybe some of those 30, 60, 90 right triangles and 45, 45, 90 right triangles, because that concept is coming back today. All right, a little recall right here about our principal values, or those restricted domains, is the fact that we had inverse sine, or remember arc sine. Inverse sine, though, is going to give you the values between negative pi over 2 and positive pi over 2. All right, just a little kind of heads up about that. That's going to give you an answer of either in quadrant 1 or quadrant 4. Okay, the inverse cosine. The inverse cosine is going to give you a value somewhere between 0 and pi. So that's going to return something in quadrant 1 or quadrant 2. And the inverse tangent is going to give you a value somewhere between negative pi over 2 and positive pi over 2. So that, again, is just like the sine. So that's going to be quadrant 1 or quadrant 4. Remember, the blue one's different. The cosine's different just because. Haha, not funny. Okay, so the blue one's different just because the inverse cosine is the different one. The other ones have the same principal values. All right, remember those principal values? The principal values are the restricted domains to help you out, so that you still have a function. All right. Okay, and when evaluating, it's often helpful to rewrite the inverse expression in terms of a trig function. It might help. All right. Also remember, inverses will always return an angle answer back. So you're going to do this to get an angle out. It might be an angle in radians, it might be an angle in degrees, but you're always going to get an angle out when you come up with the answer here. So to begin with the easier examples. The inverse sine of root 2 over 2. What you're thinking, hey, the sine of what angle is going to give you the ratio of root 2 over 2? Or where does the sine have a value of root 2 over 2? So if you use the hand method, and you're thinking, okay, I want sine. Sine is what I'm focused on. Sine's the lower half of my hand. So the lower half of my hand is what I want, and I want 2 fingers up on the lower half of my hand. So if I do that and I want 2 fingers up, which finger am I going to have to fold back? Well, that's the middle finger right there. So I fold that middle finger back, and that middle finger corresponds to which angle? Which angle is that middle finger? Oh, well, that middle finger is the angle of 45 degrees, or you can also say pi over 4, kind of like so. All right. If you didn't like that, here's another way to kind of think about that problem. Another way to think about that, if you'd rather kind of draw the triangles, you're like, Mr. Wagner, that hand trick, that's bad. I don't like that. Well, another method is to draw the triangles. Draw the triangles to kind of help you out. So if I draw a right triangle right there and I put theta in the corner, all right, and I'm talking about sine. And remember, sine is going to be the opposite over the hypotenuse. So that tells me the opposite side is the square root of 2, and the hypotenuse side has got to be 2. All right. Okay. All right. Am I looking at one of these triangles that's a 30, 60, 90, or a 45, 45, 90 right triangle? Well, you can use a little bit of Pythagorean theorem to figure out what the third side is. 2 squared minus the square root of 2 squared is going to equal that last side squared. Well, that's a 4 minus a 2 has to equal the last side squared. So that means 2 has to equal the last side squared, so the last side is the square root of 2. Oh, okay, so I can put a square root of 2 in there. Oh, okay, I see both of the legs are the same length, so therefore this is a 45, 45, 90 right triangle, so that tells me this angle right here has to be 45 degrees, or that pi over 4. So you can use that with the triangle method as well, and I'll do a couple of them with both so you get the idea of which method you like the more. All right, number 2 right there. The inverse cosine of 1/2. What you're thinking is what angle, the cosine of what angle is going to be a ratio of 1/2? Or where does the cosine have a value of 1/2? So if I think about the hand trick, right there, I'm thinking cosine. Cosine is the upper half of my hand. and I want one finger on the upper half of my hand. So which finger should I fold back if I want one finger on the upper half of my hand? You got it. It's the ring finger. So the ring finger gets folded down. What angle is associated with the ring finger? Oh, well, that's 0. That would be 30 degrees. That's 45, and the ring finger's got to be 60 degrees. So theta has to equal 60 degrees this time. Or if we were in radian mode, we would say pi over 3. Mr. Ryder, no. I'd rather see the triangle method. Sure, here's the triangle method for you. You draw a right triangle. You put theta in the corner. Cosine, you think cosine. Cosine is the adjacent over the hypotenuse. All right, so the adjacent is 1. The hypotenuse is 2. Oh, okay, I think I know what the third side's got to be. It's got to be the square root of 3. And therefore, if I know that this has got to be a 30, 60, 90 right triangle. I just have to figure out, is theta a 30 degree or a 60 degree angle? Well, it's across from square root of 3, so therefore it's got to be the bigger angle. That's got to be theta equaling the 60 degrees, which would make the 30 degrees right there across from the smaller side, which is 1. All right, so I could use the triangle method or I could use the hand trick. All right, here's another one for you. Inverse cosine of negative root 2 over 2. All right, inverse cosine of negative root 2 over 2. You're asking yourself, the cosine of theta is equal to negative root 2 over 2. Or where does the cosine have a value of negative root 2 over 2? Be careful on this one because now we're dealing with a negative. We're dealing with a negative. So just kind of keep that in mind. We're dealing with a negative right here. I'll come back to that in a little bit. All right. I want the hand trick. I want the hand trick, and I see, oh, the square root of 2 is on the top. So I want 2 fingers on cosine, the upper half of my hand. All right. So that's going to be the middle finger. That middle finger is associated with 45 degrees. Or you could also say pi over 4. However, that should give me a value of positive root 2 over 2, and I want negative root 2 over 2. So this is one of those times, because I'm talking about a negative angle, if you remember back to our all students take calculus. Oh, yeah. I don't want the first quadrant, which 45 degrees would be in. Pi over 4 would be in the first quadrant, because that would give me a positive cosine. I want a negative cosine. So I actually want to be in quadrant number 2 right there. So what angle represents quadrant 2 that's related to 45 degrees? Oh, that's going to be 135 degrees. Okay, or instead of pi over 4, I could call that 3 pi over 4. So I want the quadrant 2 values of that because I wanted a negative ratio. If you're thinking of the the triangle method there, I could put the right angle in there, I could put the theta in there. Cosine is the adjacent over the hypotenuse. So the adjacent would be root 2, the hypotenuse would be 2. All right, I could figure out the other side's got to be root 2 as well with Pythagorean theorem. So that would tell me theta would have to be a 45, 45, 90 right triangle. All right, but because it's negative, this is where we might go back up here to the top, and we might say, oh, it's got to be a value that's either in quadrant number 1 or quadrant number 2 for cosine, for inverse cosine. So that means I don't want the positive one. I don't want the quadrant 1. I want a negative ratio. I want a negative answer. So I got to go to quadrant number 2. To go from quadrant 1 to quadrant 2, I've got to take 180 minus whatever that angle is. So 180 minus the 45 degrees is going to give me the 135 degrees. Or you could also say, in this case, 3 pi over 4. Okay, it's starting to make a little bit more sense now. How about this guy right here? Inverse sine negative root 2 over 2. You're thinking the sine of theta, the sine of what angle gives you a negative root 2 over 2? All right, if you use the hand trick right there, sine is the lower half of the hand. So I want 2 fingers up on the lower half of my hand. 1 finger, 2 finger, fold that angle back. Oh, that's right in the middle. That's a 45-degree angle. So theta's got to be 45 degrees, or you're thinking pi over 4. However, there's a big old negative sign right there. Bummer, there's a big old negative sign. So if I'm dealing with a negative, I don't want quadrant number 1. All students take calculus. I'm thinking of a negative value. So in quadrant number 1, everything's positive. In quadrant number 2, sine's positive. I don't want quadrant 2. Quadrant 3, tangent's positive. That one would work. Quadrant number 4, cosine's positive. That one would work. And because of that principal values that I had, that restricted domain, quadrant number 3 is a garbage quadrant. I'm never going to use that one, but I do want quadrant number 4 because I want to try to connect it to quadrant number 1. So quadrant number 4 is where I'm at. What angle represents 45 degrees in quadrant number 4? Well, you're thinking 360 minus 45, and that gives you your 315 degrees. All right. However, one more however here, your answer's got to be somewhere between negative pi over 2 and positive pi over 2. Somewhere between negative 90 degrees and positive 90 degrees. So I've got to do one more thing. I've got to kind of go backwards 360 degrees on me. And 315 minus 360, that's going to give me a negative 45 degrees. So negative 45 is what I want. Or I could also say negative pi over 4 radians. And you can use the triangle trick for this one as well. So hopefully you've got enough of those triangle examples, and I'll be more than happy to show that to you in class if you need a little bit more with those triangles. All right, a couple more for you. How about tangents? The inverse tangent of negative 1. Inverse tangent of negative 1. All right, you're thinking the tangent of what angle is equal to negative 1, or where does the tangent have a value of negative 1? All right, so we got to know our tangent values a little bit more, and they're a little bit trickier to work with, but we can realize here, really another way to come up with tangent is we can think of the sine over the cosine. All right, so what two ratios divided will give you a value of 1? Well, it's going to be the exact same thing, so it's going to be root 2 over 2 over root 2 over 2. That'll give you a value of 1, which is pretty cool. So we're looking at the sine being root 2 over 2, the cosine being root 2 over 2, and that's going to be smack dab in the middle at the theta being 45 degrees. Or you can think of that as pi over 4, but it's a negative. Bummer, it's a negative. So I got to be in quadrant number 4, not in quadrant number 1. So the angle that's associated with quadrant 4 for 45 degrees is 315 degrees. But I got to be between negative pi over 2 and positive pi over 2. So really it turns into negative 45 degrees. Or you can think of that as negative pi over 4. All right. If you wanted to see this one as a triangle method, that one might make more sense as a triangle method right there. You're thinking theta right there in the corner, and tangent. Tangent is the opposite over the adjacent. So if I have 1, just make it the absolute value of that. 1 is really going to be 1 over 1. So the opposite's 1, the adjacent's 1, and that looks like I can use my my same sides for my legs. So I can call that a root 2. So this looks like a 45, 45, 90 right triangle. So that tells me this theta right there has got to be a 45 degrees. But because it was a negative 1, I've got to be in quadrant number 4, and that's where I ended up with a negative 45 degrees. So a couple different ways to kind of go about doing that. Inverse tangent, last one, inverse tangent of square root of 3. Again, think what you're kind of working with that one. All right, if I wanted to use the sine over the cosine, I'm thinking the sine over the cosine, and I want to end up having something be equal to a square root of 3. All right, so I could either go 1/2 over root 3 over 2, or I could go root 3 over 2 over 1/2. If I do that, that'll clean up to be root 3 over 2 times 2 over 1, which is really just going to be root 3, which is what I wanted. So I'm looking for the sine being root 3 over 2 and the cosine being 1/2. The sine being root 3 over 2 and the cosine being 1/2. So the lower half has to have 3 fingers up. 1, 2, 3. Fold that guy back. Upper half of the hand has to have 1 finger up. It does. All right, so that's going to be 60 degrees. So the theta's got to equal 60 degrees right there. Or I can think of in radian mode, pi over 3. Now, do I need to come up with a different quadrant for this one? No way, because it's positive. That's got to be quadrant number 1. So I can lock that one in. If I wanted to go with the triangle method one final time, I could draw out a little right triangle, put in a 90-degree box, put in my angle theta in the corner, and I realize tangent is the opposite over the adjacent. So that means the opposite's going to be root 3, and the adjacent's got to be 1, because I can really make that root 3 over 1. Oh, okay, I see where I can go with this. This is a special right triangle, so the hypotenuse is going to be 2 this time. and I'm trying to figure out, it's got to be a 30, 60, 90, but is it 30 or is it 60? Across from 1 is the shorter side, that's got to be 30, and across from root 3, the longer leg, that's got to be 60 degrees. So that's how I end up with my theta being 60 degrees right there. And that's kind of where I'm at. So this is kind of the process when you're trying to evaluate expressions. One thing you realize, I didn't use this thing at all. I never used my calculator at all. You don't really need it at all. You just need to make sure you review your special right triangle ratios, make sure you understand the hand trick or the right triangles, and make sure you understand all those principal values. All right. Also, the final key thing that I want to leave you with is this chart right here. Remember the blue one, the cosine's different just because, to figure out the different quadrants. All right, I'll see you next time. Bye-bye.